I mean, do you have a particular topic or any particular questions or? So you talk about like the application questions, like there's a tree and the shadow is this long, looking up at this kind of angle. How tall is the tree type stuff? Or okay. So let's just start off. I'd like to make up one of those. We'll start off with. All right. You'll get to see how great of an artist I am. Okay. I'll even see if I can color coordinate some of my great artwork here. So, yeah, let's say that we have this beautiful tree. Okay. Okay. It's obviously a tree, right? Okay. All right. So let's say that we have this tree, and it casts a shadow that is 12 foot long. Okay. And if you look up to the top of the tree, that the angle of elevation is, let's just say, 23 degrees. Okay. Question would be, how tall is the tree? So you got any ideas where to start? Okay, so if you get up like the right triangle, we got the 90 degrees here, 23 there, and that's going to make it all right, and we know that this side is also 12 foot. Right. Now, ultimately, what are we looking for? Okay, which side of the triangle? Okay, so this is the part that we're actually ultimately looking for, right? So any thoughts about? Okay, so there are a couple of things that you should always think about with these right triangles, okay? One of those is the famous Pythagorean theorem. Man, that did not look like a 2. Okay, so there's our famous Pythagorean theorem, right? A squared plus b squared equals c squared. Okay, do you know what the a, b, and the c stand for? Which parts? Okay, so no. Okay. So the Pythagorean theorem always references the sides of the triangle, not the angles. Okay? The A and the B are the short sides. Okay? And then the C is the long side, or the hypotenuse. We want to use our fancy terms. The A and the B are the legs. The C is the hypotenuse. So if you square the legs, the lengths of the legs, you add those up, should be the same as the square of the hypotenuse. Okay? That's always my first thought when I see a right triangle and I'm looking for a side. My first thought is always, hey, can I use the Pythagorean theorem? Okay? But to use that, I need 2 of the 3 sides. And I don't have 2 of the 3 sides. Okay? So first thought goes out the window. Okay? In a trig class, the next thought is to use either the sine, cosine, or tangent. Now, for the sine of an angle, now do you remember which? Okay, so when you think about sine, cosine, and tangent, let's just think sine, okay? Do you know what that is? Yeah, do you know? Okay, so sine, cosine, and tangent, okay, are still, all they are is they're a fraction, they're the ratio of 2 sides of the triangle. And sine and cosine and tangent are just picking different sides, okay? So the sine is the opposite side divided by the hypotenuse, okay? So it's the ratio of those 2 sides of the triangle. Okay? In this case, okay, if I go back and label, I don't know that one, I don't know the other one either. So I'm just going to call them, let's just call them x and y for a second, okay? Just knowing I need to find and figure out what x is, okay? So if we look at this angle 23 degrees, okay, the opposite side divided by the hypotenuse. So the sine of that one would be x, oh, go away there. Sometimes me and technology don't get along so well. It's going to be x divided by y, okay? Now, in each case, I'm going to go ahead and start filling in some blanks. Okay? So I know the angle that I'm thinking of right now is that 23-degree one. Okay. Now, the cosine is the adjacent side over the hypotenuse. So the adjacent side is the one that's touching it and not the hypotenuse, okay? So the adjacent side was the 12. So this is really adjacent divided by hypotenuse. So in this case, that is the 12 divided by y. Okay. Now the tangent is the opposite side divided by the adjacent side. So the opposite side in this case is x, and the adjacent side is 12. Now what might be handy for you, okay, before you start doing a lot of this stuff, okay, because to use sine, cosine, and tangent, all of that is based off of which angle you use, because it's going to change if you switch angles, okay? So let's say whatever I do in this problem, I'm wanting to use that 23-degree angle. It doesn't matter if I use that one or the 67. You get the same stuff in the end, okay? So you got to pick one, okay? It might be a good idea to go in here and say, you know what? Let me label them, because if you go all the way across, that's always the opposite side. Okay? This one's the hypotenuse. The one that you don't label yet would be the adjacent side. So it might be handy to actually put like a little label on there, because what people do when they're taking tests especially is they start mixing and matching those numbers. And if you label things, sometimes that allows you just to kind of focus in, and it kind of sticks in your mind for just a second which one's opposite, adjacent. You don't make as many stupid mistakes, okay? So I look at all of this stuff that I have written down, and this is just kind of a problem-solving trick, because a lot of times we don't know exactly what we need to do to solve some of these problems, okay? And when the teacher does it up there, it's like it's magic, right? Well, how'd you know to do that? Okay? It's because we eliminated a lot of other crap first and we just didn't tell you, okay? So when I see any kind of basic right triangle, my first thought's the Pythagorean theorem. And I go, okay, I could fill in the blanks with that Pythagorean theorem, okay? And that would be 12 squared plus x squared equals y squared, okay? Then I could fill in the blanks with the sign and stuff like that. Now, when I'm writing it down, and I'll put these kind of back up here in a second, all I'm really thinking about is this deal, okay? Sine of 23 equals x over y. Cosine of 23 equals 12 over y. Okay? And then I look at all my options, okay? And then I decide which one's easiest, okay? There's two variables here. And there's two variables here. And there's one variable here. And there's only one variable involved in this one. Okay? Well, the heck with these. That's twice as much work. I'm lazy. No, I'm efficient. Okay? Efficient. Okay? So there's only one variable involved in either one of those. Okay? Which one is the one I'm looking for? So yeah, so why would I want to know this one? Oh, so tangent of 23 equals x over 12. That's the equation that I want to use to solve this problem. So don't think there's like some magic, you always know when to use what. That's not what goes on, right? What goes on is think of all the stuff that you know about the problem and eliminate the hard stuff, okay? And the stuff that you don't know, and try to narrow down your options, okay? Because if you try to memorize when to use sine, when to use cosine, when to use tangent, you're going to be hard-pressed to memorize all of that stuff, okay? So this is what I want to focus on. Now, keep in mind, tangent of 23 is a number, okay? It's a funny-looking number, okay? But it's a number, okay? So just think about it like any other number out there, okay? And remember, it's not times, it's not tangent times 23, okay? And that's a lot of people always, they see that and they want to think that they're multiplying by 23. No, it's the tangent of a 23-degree angle, and it's some kind of weird decimal, okay? Now, but the key is I've got to solve for x. And that's x divided by 12 equals this number. How do you get x by itself? No. I don't even care what that number is, okay? Just tell me what process, what step do I need to take to get x by itself? Multiply 12 with both sides, right? So that would just be 12 times tangent of 23. Oh, wait a minute. If we need a decimal, I can type that in the calculator. Now, I say it like this because, one, you should wait as long as you can to type that stuff into the calculator, because if you do it real early in the problem and you round off, and then you start using that rounded number, by the time you get to the end, your answer may actually be fairly substantially off. Okay? So if you wait until the end to do any rounding, and the other thing is you've got to make sure that you're in degrees on your calculator and not radians. Okay? Super careful about that because it's easy to forget and easy to fix. So this turns out that our little tree is just over 5 foot tall. So what's still a baby tree? Okay? Now, a lot of teachers as well expect that if they give you a word problem, that you answer your question in a sentence, right? So I would write, the tree is 5.09 feet tall. Okay? A lot of teachers expect that if they give you a word problem, that you answer as a sentence. And they will actually probably make count off if you don't. Okay? So that's just kind of a little, not all of them do, but quite a few. Okay? But it doesn't matter. It doesn't matter what kind of question they give you. It could be, you know, let's just say we have a little dock on the beach here. Okay, it's a beautiful river and a dock. Okay, and then somewhere out here is a little sailboat. Okay, and that sailboat's been floating around, but not straight out from the dock. That would just be way too boring. So he sailed off kind of in this direction. Okay, told you my artistry is awesome. Okay, and let's just say for a second that. Have y'all talked yet about like the bearing of things or heading? It's when we talk about something being 30 degrees north. Okay, you'll get there. Okay, but let's just say for a second that for whatever reason, this guy decided he was gonna. We'll start off with a nice easy one. Sail due north. And he went for 12 miles, okay? And then he turned, made a 90-degree, went due east, and he went for 15 miles. Okay? Question is, how far from the dock is he? Do what? Okay, so that's what we're looking for then, right? This piece right here. Okay. And so think about your, and I always think of it kind of in my head, there's four basic formulas: the sine, the cosine, tangent, the Pythagorean theorem. Okay? And I always start off with the Pythagorean theorem one. Okay? If I start off with the Pythagorean theorem one, that gives me 12 squared plus 15 squared equals, and we'll just call that x again. Okay? We'll just call that side x. Well, I'm not even going to bother finding the rest of them, because what I'm looking for is the side. That's the only variable involved. Okay? So, what do we get? 144 plus 225 equals x squared. So that's going to give me down to, if I combine my like terms there, 369 equals x squared. Now, I don't care what x squared is. All right, what I care about is it's x. So what do? Okay, and if I take the square root of 369, what do you get? Are you sure? I like that you have confidence in your answer. Okay. I'm going to bring up a point. This thing lies. Dang it. It lies. A lot. Your confidence, in this case, will accidentally lead you to the correct answer. Okay? By that, what I mean is calculators are only programmed to do certain things, and it's up to you to think about the things that they tell you. Okay? That is not your only possible answer for that square root. Okay? There is also the option of a negative. Think about, let's digress here for a second, the square root of 4. That's what number times itself is 4, right? Okay, well, 2 works. But doesn't a negative 2? Because a negative times a negative is a positive, right? So every time that you take a square root, you need to think about that there is a positive and a negative. Okay? In context of this question, though, we're talking about the number of miles something is away. Can something be a negative 19 miles away? Okay. So we would throw that answer out simply because in context of the question, it doesn't make any sense. So just by relying on the positive, you would get the right answer, right? But if this were a similar question and you were just solving an equation that has squares and stuff in it, you've got to make sure that you consider that the negative is an option. The question is whether that option makes sense and whether you keep it or not. Does that make sense what I'm saying? Okay, so you do have to be a little bit careful when you do the square root stuff, but when you're talking about distances, positive. However, if you get into physics questions and stuff, sometimes the negative indicates a direction. So it might be that the positive means I'm going to the right and the negative means I'm going to the left. Okay? So always consider the different possibilities, okay, in context. Now, I could make this a little bit more complicated, okay? And because I'm a math teacher, we like to do things like that, right? We always take something simple and make it worse. Okay. So let me see if I can make one up off the top of my head here. So same kind of setup, okay? There's a little beach down here, and we've got a little dock, okay? And we got our boat. But this time the captain of the boat's drunk. Okay? and so he takes a twisty, turny path. Okay? So maybe he starts off and he goes, about 5 miles out. Okay? And then he takes a right-hand turn and maybe he goes another 7 miles out that direction. But then he's off at an angle here. Okay? And let's say he turned and he made a 25-degree turn. Okay? And he stayed on that path for about 10 miles. Let's say that's complicated enough for right now, because it'll get the point across without making it too awful. Okay? So now the boat's there. Let me draw him in the right spot here. Okay? How far away is the boat now? Wait a minute. Let's just see. Let's play around for it. There's going to be some useful information here. Okay? I think the first thing that I would do is start breaking it up into smaller pieces. Okay? Because ultimately, what it would be nice to know is how far over and how far up that guy went. And then that would tell me I could use that information to find that leg, right? Okay. All right. So if I knew how far over and how far up, I could figure it out from there, because then it's exactly like that last question, right? Okay. Well, if I carefully kind of consider what's going on here, and I just think about the how far overs, all right, and the how far ups, I've got two right triangles, right? And the base of, hey, I drew a big old fat purple line. All right. The green bases there form the whole bottom of that big red triangle, right? And then the purple sides form the side of that. Could I find those individually? Okay. So let's just tackle the first triangle. Okay? Oh, wait a minute. I already know how far over. Okay? I don't need any other information from that, because I'm not really looking for its hypotenuse, right? All I'm wanting to know is how far left, right, how far up and down total, because the hypotenuse of the big triangle may not line up with the two smaller ones, right? Make sense? Okay. All right, so all I really know is now I can focus in on that second one and go, okay, well, I've got this triangle, and I know this angle is 25 degrees, and I know the hypotenuse is 10 miles. And what I need to know is the length of the bottom leg and that vertical leg. So again, my first thought is the Pythagorean theorem. But again, that leaves me with two variables. But then I can think, oh, well, sine of 25 degrees is the opposite over the hypotenuse. The cosine of 25 degrees is the adjacent over the hypotenuse. And the tangent of 25 degrees is the opposite over the adjacent. Okay. Now, I would strike out both of those, because right now, all I need to know is x and y. And I have an equation that involves just y and just x. So why have more complicated ones? So let's just start off with that top one. Sine of 25 equals y over 10. So what's my y equal to? So how do you solve that one? So y is approximately 4.23. Okay? And then same thing with that cosine then. We know that cosine 25 is x over 10. So we multiply that. And we get 9.06. Now, here's been what we have so far. And I'm going to kind of redraw just the triangle down here. Okay? We had that big triangle. It was in red. Okay? And we had one piece that was 7 miles. And then this piece is 9.06 because that was my x, right? Okay? And then we had, like, was it 5 miles? Yeah, he went 5 miles up. And then the other purple line was the other y, which was 4.23. So if you'll notice kind of, if I kind of color coordinate what we had here, these individually were those purple sides, and then these were the green sides of the little triangles, right? But now at least I've reached my first goal, right? Because I said if I know the sides of the big triangle, then we can use that Pythagorean theorem to get the actual distance for the boat. So I'm going to call that one D. Okay. So the total on this side then would be what, 16.06 for this whole side. This one would be not a calendar, but 9.23. So what's my Pythagorean theorem say about this? What would be the little equation for it? Okay, so the Pythagorean theorem, you take the two short sides and you square those. You add them up. And that equals the hypotenuse squared. Okay, so you're going to square all the sides. Okay? And it's always going to be the short one plus the short plus is equal to the long. Okay? So think about these sides. The hypotenuse is always the one across from the right angle. Okay? So that was easy to identify because this over here would be the long side, right? So it's always short squared plus short squared equals the long squared. So that would give me 16.06 squared plus 9.23 squared equals that long side squared. Sometimes what I write down isn't necessarily what's in my calculator, okay, or what I'll use, because in my calculator it's 343.1165, okay. I'll actually use that number when I go to do square roots and stuff, so that way I'm not rounding too much. I'm just too lazy to write out all that, okay. So as you follow along, if you were to type in right now the square root of that, you're going to get something different than what I'll wind up having, okay, by just a little bit. Okay. So when I take the square root, we're going to wind up with 18.52, potentially, right? Let me see how different it would be, 343.12. Okay. So if you typed in just what I had written on the screen, it would be 18.52. It's just a little bit different, okay? But in the calculator, to avoid too much rounding off, what I did was once I got the 16.06 squared plus 9.23 squared, and then I hit the enter sign, and it pops up on the screen with the 11, 3, what was it? Yeah. 343.1165, but then I just hit the second square root. And then second that for the answer. Okay? And then on the screen, what pops up then is square root A and S, close parentheses, and it'll use that full decimal instead of the rounded one. Okay? Y'all use WebAssign? WebAssign for your homework and stuff? Okay, I couldn't remember which book we're using nowadays. So you got to, I bring this up because computers are really picky, right? Like I said earlier, if you round off real early, it can be off by just enough that it may have done the whole problem right, and it's counting it wrong because of a rounding issue, right? Try not to round until the very, very end, okay? All right, but does that strategy that we use to make sense breaking up into the smaller pieces and just, so, you know, usually the first thing is to figure out, what am I looking for, right? Completely ignoring what pieces you're given. And I'm saying, well, if I'm looking for that distance, you know, what I'm looking for is that right triangle, okay? And then I think, well, if I want the side of a right triangle, I need either the other two sides, or I have to have at least one side and an angle, okay? So then once I identify kind of what I'm looking for, then I can look at those little pieces and see how they fit that, okay? And I do silly things, color coding stuff, things like that help split the picture up to me, and make those little pieces a little bit more obvious. I don't know, I do lots of little things like that to help from making those goofy mistakes, okay? And not only that, but seeing how those pieces kind of fit into the bigger picture, okay? In a trig class, for me, it is essential to draw pictures, okay? I cannot read a trig question, one of these real-life made-up things, right? Right, these word problems. I cannot read a word problem and go, hey, I know exactly what to do. It doesn't happen, okay? I can read a word problem, and from that, I can build a picture, and then I can see what I need to do, how those pieces are connected, okay? Even, and you'll notice, even on this really, really simple one, I drew a whole separate right triangle and I started labeling stuff. Now, did I need to do that? No, I mean, I have a right triangle drawn with a tree. But there's something about just drawing that diagram as a triangle that helps me figure out what I'm doing, okay? So when I say draw a picture, it's that sort of stuff I'm talking about even on the basic ones, not necessarily drawing trees and boats, okay? You know, on an exam or something, I wouldn't have taken the time to draw a little dock and a boat. I just took a dot there and started tracing it out, right? You have to memorize the Pythagorean theorem and your three basic trig functions. Okay? I mean, there's other stuff that you're going to need to know too, but if you don't know those, you're not going to pass the class. I mean, it's the foundation for all of it, okay? So I'm going to digress just a little bit. There's a couple of ways that people tend to memorize the trig function, okay? Some people spell out SOHCAHTOA. Now, here's my problem. I'm a math geek. I can't spell worth a crap. So while I can hear the word SOHCAHTOA, I wouldn't have a clue how to spell SOHCAHTOA. So it didn't help me a whole lot, right? But a lot of people do find success in remembering they can spell that. They remember it. And it's sine, right? Opposite hypotenuse. So sine equals opposite over hypotenuse. And then it's cosine is the adjacent over the hypotenuse. And then tangent is the opposite over the adjacent. Okay? So it just kind of gives an order of which ones are connected to what. Okay? So myself, I can remember sentences a little bit easier than spellings. Okay? So how I remember it to this day, okay, is I always put it sine, cosine, tangent in that order. Okay? Right. So I just memorized an order, sine, cosine, tangent, and then Orville had a heap of apples. Use the first letter of each one. Orville had, opposite over adjacent, or opposite over hypotenuse, a heap, adjacent hypotenuse, of apples, opposite adjacent. Okay? So this, when I stop, I swear to this, even to this day, when I'm starting to write sines and cosines, that sentence goes to my Orville had. Okay? And those are probably the two most popular mnemonics that I've seen. Okay? But the, do what now? Yeah, no, I have heard that one. Okay? So however you can remember that order, you need to know it. Okay? Now, I'm loosely using the phrase when I tell you have to memorize it. Okay? You have to be able to at least write it down quickly enough that you're not losing time on the exam and stuff like that, right? So when you get the test, the first thing that you should do is write these formulas down. Okay? Before you even look at question 1. Write down your Pythagorean theorem, write down your basic sine, cosine, tangent definitions. Okay? And then as you're taking the test, you can always just quickly go back and reference it without having to every single question stop, think about it and waste time. Okay? Also, if you write it down at the beginning of the exam and you haven't gotten yourself confused by a question yet, you'll probably write them down correctly. But if you read a question and you start getting confused, then that spills over a lot of times into formulas and you start writing formulas down wrong. Okay? So write them down first. Take 30 seconds. Write those down, then start the test. Okay? All right. But all of those application problems are kind of like these. They give you an angle and a side, and you got to use tangent, sine, cosine, whatever. They give you a couple of sides. Use the Pythagorean theorem. And maybe it's even sometimes a combination of those things. Let's say you got a building, okay? And you got somebody standing on top of it. Now let's say you got somebody standing down here, so many feet away. Right? Let's say they look up at this guy. And they look up and it's a 75-degree angle of elevation. Right? They then walk away from the building. Okay? And they walk another, let's say, 50 feet. Okay? From where they started to where they ended. And now they look up and they are looking at a 50-degree angle. So they look up at a building, 75-degree angle of elevation. That's what they got to look up at. So anyway, the person standing there, he's looking up 75 degrees. Then he takes off and he walks 50 feet away. And he looks up, and now he's looking at a 50-degree angle. How tall is the building? Okay, so it would certainly be nice. Let's just call that one D. Okay? It would certainly be nice to know that. You're right. That would be a great first step. Okay? If you knew that, what would you do? Because I only have what? Yeah, I only have that one long side, right? Okay. Or that one bottom side. Okay. I do have some angles in there. So we can't use the Pythagorean theorem, so that means we would have to use what? What are my three options? Okay. So now you're kind of focused on like the big triangle here, right? Or are you focused on the smaller triangle? Do you see a smaller triangle? Okay, yeah, because we have the smaller triangle that's in here, right? But thinking about the height of the building, man, if I knew that little distance, I could even use the smaller triangle to find that height, right? But I don't know the little distance there. What do we know? Let's just start listing things, all right? Okay? I do know that and let's just, I'm going to label these so it's easier to write. So I'm going to call that side H for height. And then this side we're just going to call Y. Why not? Okay. So there's the Pythagorean theorem, but we already decided we weren't going to use that. But just for the sake of completeness, I'm going to kind of write it down. Okay. But that's got three variables in it. Okay. Now, the other things that I know, let's focus on big triangle right now. Okay. Because I got to start somewhere. Is that the sine of 50 is the opposite over the hypotenuse. The cosine of 50 is the adjacent over the hypotenuse. Now, the adjacent side is the 50 plus b, right? And then the tangent of 50 is opposite over adjacent. So I know all of those things about it, right? Okay. That doesn't seem to help a whole lot yet. Okay. But what else do I know? Oh, I've got the small triangle. This is part of problem solving. Start listing the things that you know, okay? Or the things that you can figure out from there, even if it's just this basic definition stuff. With the small triangle, okay, let's see, my Pythagorean theorem would be d squared plus h squared equals, I guess I got to call this thing something. So let's call that little side x. I haven't used x yet, okay? And then my trig functions. Okay? So my trig function stuff, we have sine of, in this case, 75 is opposite over hypotenuse. Cosine of 75 is adjacent over hypotenuse. And tangent of 75 is opposite over adjacent. So then I'll look at these lists of whatever language that is. Okay? Do you see any connections between any of those things that might help? All right, so I'm going to strike out Pythagorean theorem stuff right off the bat because there's just too many dang variables. Okay? All right, now I keep saying that. And remember, anytime that you discard something, it's only temporary because you might be wrong. So I shouldn't say I'm not going to use it. I'm going to say I hope I don't have to use it. Okay? because they both look a lot more complicated than other stuff. Okay? So it's more of a hope. Now, I look and I start comparing signs. One side has H's and Y's, the other side has H's and X's, and at first you're like, oh, they got the same stuff. No, they don't. One has H's and Y's, the other one has H's and X's. Now they have H in common, which is good, but then the other variables are different. Okay? Same thing with cosine. They both involve a D, but one's a Y and one's an X. But then I look at tangent, and I go, ooh, H and D on this side, H and D on this side. At least they involve the same stuff. Okay? So this is where I'm going to focus my efforts. Because there's only 2 variables involved, where the rest of them had 3 or more, right? All right, now we're going to take a trip down memory lane into algebra. How good's your algebra? Right? All right, we've got just a few minutes, so I'm going to step back. And we're going to ignore this problem for a second, okay? All right. If I gave you this system of equations and told you to solve that, do you remember how to do that? You had what? Okay, so moving forward, we expect you to remember all that stuff. Perfect, okay? Perfect clarity on everything you've done in math. We really don't. It would be nice, though. So there are several different ways that you can solve system of equations. So a system of equations is when you have more than one equation and you want to find a solution that works for both of them at exactly the same time, right? Okay, so there's 2 algebraic methods that we can use to get the exact right answer, okay? One of those is substitution and one of those is elimination. Okay. So either one will work, okay? I'm going to choose to use the substitution method, okay? Substitution method says if you've got one of your equations solved for one of your variables, like this first one, y equals stuff, okay? That you can take whatever that is and replace it in your other equation, okay? So since y and 2x plus 1 are the same, I mean, that's what the equal sign means, right? They're the same. They're interchangeable. Since y and 2x plus 1 are the same, they're interchangeable, right? I mean, that's what an equal sign means. So what we're going to do is we're going to say, okay, well, let's switch out that y for the 2x plus 1, and the advantage is now I have one equation with one variable. And I can solve that, okay? Right, so I'm just distributing and combining my like terms and stuff. So we'll subtract 2 from both sides. You get 7x equals 4. So x is 4/7. Now, if I need to know what the other variable is, I could go back to that first one that said y was equal to 2x plus 1, right? Now I know what x is. I can substitute that in for the x, because I know it's now equal to 4/7. That's 8/7 plus 1. So I got to get a common denominator. So that 1 would be 7/7. And now I know what the other variable is equal to, because that's 15/7. Okay? So that was the method, one of the methods you should have seen back in 112, or like the 111. Okay. we're going to do that exact same thing with these two equations. These just look worse because we got tangents involved. But remember, tangent of 75 is a number, okay? Tangent of 50 is a number, okay? Now, if it makes you feel better, there's a good little trick that you can use as far as visual stuff, okay, with the calculator. Because you could say, you know what, just to avoid things, I'm going to call tangent of 50 A. Realizing that it's just a single number. It's not a variable, okay? Now, you could, if you wanted, go ahead in your calculator, do tangent of 50, and come up with 1.19, okay? Now, there's two problems potentially with this. One, like I mentioned, rounding errors. If I use 1.19 for the rest of my calculations, my answer is going to be off a little bit. Okay? Two, if your instructor asks for an exact answer, that ain't going to cut it. Okay? So, I'm going to stick with just using tangent of 50. But just realize it's a single number. You can't separate the tangent and 50. Okay? All right. Focusing in on this equation, I could multiply both sides by d. And then I have that situation that I wanted. A variable equals other stuff, just like the y equaled. So I can make that substitution. So in the other equation then, I could do that. You okay with that substitution? And it starts looking a little funny, right, with all the letters running around. Okay? Like I said, a lot of times if you want, but you've got to be careful in your own mind keeping track of stuff that some people would just rather have, instead of having tangent of 50, use an A as a placeholder. Then you could use like B as a placeholder for tangent of 75, if that makes you feel better. Okay? And it does for some people. There's less letters running around. Okay? You could, if the instructor doesn't ask for exact answers and stuff, go ahead and evaluate and get 1.19 whatever and whatever tangent of 75 is, okay? And use actual numbers. You could do that, okay? I'm going to work it out like an exact answer because that's the harder question, okay? Practice at it. All right, so you know what? I'm going to erase this stuff so that way I got room to continue writing. So we've got that equation. And it's one equation and one variable now. And it's not the easiest equation. It's a little tricky because it's got stuff in numerators and denominators and whatnot. So the first thing I'm thinking about doing is getting rid of the fraction. Okay? So I'm going to multiply both sides of this by that denominator. If I do that over here, notice over here, you know, those cancel out. And then over here, we just have 50 plus d times tangent of whatever that number is. Okay? But I still, at some point in time, have to get, I'm looking for d. That's my only variable. Okay? I need to get the stuff with d's on one side where I can combine them. Okay? So what I'm going to do right now is I'm going to take and use my distributive property. I'm going to multiply that stuff by everything that's inside the parentheses. So that's 50 times tangent of 50 plus d times tangent of 50 equals, over here it's d times tangent of 75. Think about if you had a times 50 plus d equals d times b. You would distribute that a, right? 50a plus d times a equals d times b. But if a is tangent of 50, you see it's the same thing. Okay? Those are like terms, but they're on the wrong side of the equal sign, right? But if you had a 5x equals, 3 minus 5x equals 6x, and you had like terms, but they were on opposite sides of the equal sign, how would you solve that? Right, you take whatever has the term that you want to move, and you do the opposite. If it's subtraction, you would add it to both sides. If it's, right? Well, I'm adding this thing, so I'm going to subtract that whole term. So that's going to leave me with 50 times tangent of 50 equals, now I could write this one of two ways. Write it like that. Now if I can get this thing to erase, that would probably help. I'm getting confused, but it doesn't like me. There we go. Okay, so I'm just moving it to the other side, change the sign. You okay with that? I could factor the d out of that. The reason I might want to do this is look at it and I go, look, I still got two terms with a d running around. And I need d equals, right? That's my goal in my head. A d and an equals. Not something with d, something with d equals. Okay? And I realize if they both have d's and I factor those out, I'm now down to one copy of that d running around. Right? And it's d times some ugly number. Okay? And if it's d times that ugly number, how do you get rid of the ugly number? Keep in mind, it's d times ugly number. You divide by ugly number, right? Because that's how you undo multiplication. So I'm going to divide by the ugly number. If I do it to that side, I better do it to this side. But this stuff will then cancel out. We're just left with 50 times tangent of 50 over tangent of 75 minus tangent of 50. And that's the exact answer. I now have d equals something super ugly. Okay? Now, I'm not done. That didn't answer the dang question. Oh my God. Oh my God. Okay? All right. Because after all of this, what was the original question? Well, we got to go back and look, right? Aha, right. We wanted to find the height of the building, but right now what we found was, but this was your original goal. You asked what D was. And if we knew that, we could find out what the height was, right? Okay. So we've gotten an important piece of information out of it. We're just not done. Okay. But remember on the system of equations, we said once you find the first variable, you can go back and substitute it into that second equation to find out what the other one was, right? There was our other equation. I know what D is now. H, which is ultimately what I'm looking for, is just the tangent of 75 times D. Pick a color. Come on. Erase now. I need some room. So we had D times tangent of 75. So we had that D times tangent of 75 is equal to H. And H is what I'm trying to find. So 50. Just going to write in weird colors and bother me for a second. Tangent of 50 over tangent of 75 minus tangent of 50 times tangent of 75 is equal to my height. Now, just for my own peace of mind, I'm thinking about that as being over 1. It's a fraction times a fraction. I could write this as just a single fraction here. And then that would be the height. Now, can you tell me how many feet that is? I mean, I don't have a clue what that is. Okay? So more realistically, myself, when I'm teaching this class, I like people to answer in some sensible manner. And if I ask you how tall it is, I want to know how tall it is, not some gibberish, right? But I could go ahead and type this into the calculator. 5 times tangent of 50 times tangent of 75 divided by tangent of 75 minus tangent of 50. This is a really short building. And it's only like 9 foot tall. Making sure I type stuff in right and I got parentheses all in the right spots. Make sure I didn't change my mode back. Okay. Insert parentheses. Oh, hold on a minute. You stop that, you stupid calculator. Now I've done went and where did the 5 come from? Right here. Shouldn't that have been 50? Now, so here's here's an important thought, okay? A 9-foot tall building seems a little bit unreasonable. Do you know any 9-foot tall buildings? It's a kid's playhouse. Okay, so one, I made up numbers to start with. Maybe I just picked some bad extent numbers. You know, I mean, that's possible, right? If I'm just sitting here just making stuff up. That typically doesn't happen on an exam, though. Okay? We're usually a little bit more careful. And so I look at this number and I go, that seems unreasonable. So let me go back and double check to see if I did something dumb. Okay? I'm confident that I have the process right. What I'm not confident in is, did I copy every line down wrong? Did I accidentally multiply something wrong? Having a 9-foot building triggers this response of, let me go back and double check things. When you have an answer that seems unreasonable, that should be one of your defaults. Okay? Go back and double check. Don't just accept it. But then I go back and look and go, no, that should have been a 50, and I copied it onto the next line as a 5. Okay? So if I correct that mistake, then I'm coming up with an 87.5-foot building. That seems a little bit more reasonable. If I'm standing there looking up like this, it ought to be a bit taller, right? Okay. Is that okay? I mean, you kind of gave me a topic, and I kind of started running with it. I've got some more time if you have other questions. I know we were supposed to stop at 4:45. Do what? All right. Okay. Right? Okay. All right. So we want to find sine of theta. That's 1/2, and we're given that, and we want to find tangent of theta. Okay. So I want you to think about the unit circle. Okay. Now, when we pick a point on that unit circle, because y'all have talked about the unit circle, right? Okay. That we look at the x and the y coordinate. Okay. And the ordered pair is going to be the sines and the cosines, right? And which one's which? Is the x-coordinate sine or cosine? Yes. Okay? Because it's the adjacent side over the hypotenuse, right? X is the adjacent side to theta. All right? So this is always cosine of theta, sine of theta, the x and the y coordinates. Okay. Now, when I start this problem, I actually kind of ignore the negative thing. Okay? Because I tend to think in terms of the triangles, but then I've got to do a little bit of extra work to get the right quadrant that it's in and stuff. Okay? So what this is telling me is that I go what I was about to say. Here, think of it in terms of that triangle. Okay, this will be probably maybe the easiest way to do it. It's the opposite over the hypotenuse. Just ignore the negative for now, okay? So that means not a unit circle anymore, but just a circle, okay? That this side is 1 and this side is 2. Okay? I could use that Pythagorean theorem and say I can find that because x squared plus 1 squared has to equal 2 squared. So that's x squared plus 1 equals 4. So x squared is 3, subtracting 1 from both sides. So x is the square root of 3. So far, so good? Okay. Well, I now know all the sides for that triangle. Okay? So looking at that triangle, and right now I'm still ignoring the fact that it was a -1/2. I have to deal with that, but I'm going to do it in a minute. Okay? So for right now, I'm going to call this theta. Call it something if I can get it to right. I'm going to call this theta hat. Okay? Because it really is a different angle than the one that I have, but it's still going to give me some information. So I'm curious. What is the tangent of theta hat? So it's which side over which side? Tangent is opposite over adjacent. Okay? Opposite over adjacent. So that would be 1 over square root of 3. Okay, we've done the hard part now. Okay? Sine being negative, okay, that's the y coordinate in your circle, right? Which means, since sine is negative, the angle that we actually want is down here somewhere. Because the y is negative. That make sense? Okay? Now, it's still on a circle. They still have the little triangles, still all have the same sides and stuff like that. It's just some are headed in a different direction, right? Okay. Tangent, this is all you have to remember, is sine over cosine, right? If theta is here, then in quadrant 3, both cosine and sine are negative. Because you go left and down. X coordinate, y coordinate, right? Well, negative divided by negative is positive. Okay? So if theta is in quadrant 3, tangent of theta is a positive 1 over square root of 3. Okay. If theta is in quadrant 4, here you go right and down, so it's positive and negative. Cosine is positive, sine is negative, right? Positive over negative is negative. So if it fell in that quadrant, it would have to be negative 1 over square root of 3. And I don't remember your question if it said, so it said quadrant 4, so it would have to be that one. So when I see those questions, I do everything in quadrant 1 because I can deal with the positives. I find the sides of the triangle. And then I just think about whether things are positive or negative to figure out what the sign of tangents are, right? And that will change depending on which quadrant it's in. Does that make sense what I'm doing?